represents addition below 10. Okay, class, let's begin. What is 5 plus 3? We can solve.
Dr. Ramatsetse, over to you.
Morning, morning. Can you all hear me?
Yes.
Thank you for coming and attending this session. I hope you are all excited today. Are you all excited?
Yes.
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 Get a yes.
Daddy.
Yes.
So I'm going to share my slide now. I hope you can all see my slides.
Yes, we can.
Yes.
So welcome again. So today we have a very interesting topic. We are going to talk about automation. We are going to talk about robotics. We are going to talk about factories of the future. I think last week Professor Mpofu spoke lengthily about robotics. So I'm going to continue from where he left off about robotics. Can anyone still remember the topic for last week? What was presented last week? Does anyone remember?
I do.
Yes, can you tell us?
Robots.
What about robots?
We were learning about them yesterday.
Okay, what did they say about robots?
We were talking about what robots can do, if they can do this and that, how robots can help the world.
Wow. What about the others? Did you learn something last week?
Yes, that's I learned that some robots, like in some places in China, right? They have a robot that stands at the door, and then it checks the temperature, and then it says, "Have you had the fever? Have you had this type of symptoms?" And then if the person says yes or no, if he says yes,
Wow.
he says,
I mean, some people were listening then.
And then when they continue, they get to another robot which will put them through to the doctor, and the doctor will talk over the computer.
Wow. Thank you for that background of what transpired last week. However, this week, I hope everyone has their Bible. Did you all bring your Bible?
What?
Bible. Your Bible? Anyone who has a Bible nearby?
Not exactly.
Anyone, please, if you can get your Bible so that we can.
I didn't.
I haven't.
Thank you. So today we are going to read from Psalms 139, verse 14. Can you read for us, please?
I praise you because I am fearfully and wonderfully made. Your works are wonderful. I know that I know that full well.
Thank you for sharing. So I think we spoke lengthily about this last week, but I also just want to emphasize this message again, that we are all wonderfully made, meaning we've got amazing capabilities that no other creatures has. We have capabilities, we can do almost anything. I mean, we spoke about our eyesight. Our eyesight are so amazing. There's not even a single robot in the world that can see like us humans. If you can check also our sensing abilities, the way we sense, our brains as well, the processing of information that we have within our brains. There is no robot that can be up to that level. So we are all wonderfully made, and we all have these capabilities that allow us to also create things that can assist us within the world. I think it also links to the scripture of Genesis 1, 26 to 27. If someone can also read us Genesis.
Sorry. This is what?
So God created man in his own image. He created him in the image of God. He created them male and female.
Yes, we are all created in the image of God. And like Psalm says, we are all wonderfully made. So I think it also links to the message that I shared, to say we must always remember that we have amazing capabilities like no other creatures in the world. So we must always keep this to their heart. We must always see ourselves as the best creatures, because we are wonderfully made and we are created in the image of God. Thank you for reading, my friend. So I think Professor Mpofu spoke a little bit about robotics last week. I think when we started, people gave a background of what they had learned last week. So we are going to also take it further this week and understand more about these robotics. So we define robotics as technology that can help us to dealing with designs, construction, and operations of robots in automations. So those are some of the things that we can take into account when we are dealing with robots. So let's look at how all these links together. My topic for today, I said, is automation, robotics, and factories of the future. So how do they link? So we usually have robotics, which you can say they are machines, they are at machine level. We also have automation, which happens due to the robots also in the system. And lastly, we also have factories, you can say smart factories, where all these activities are happening. So at machine level, we speak of robotics, which are machines designed to execute one or more tasks automatically with speed and precision. So just remember that we can automatically perform tasks with speed and precision. Sometimes us human beings can be slower. Sometimes us human beings cannot be precise. But because we created these robots, they can help us achieve the activities at the speed that we need as well as the precision. So just to see if everyone has learned and understood what's transpired, for what other activities do we need robots? Why can't we just continue to do things ourselves? Can someone raise their hand? For what other activities do we need robots? For what other activities do we need robots?
Need robots for operations, because maybe there's something in a human's body that we cannot touch that is very sensitive, and we need a robot to get to those small parts in the body.
Yes, the precision that is required to perform such tasks, especially in operations. So that's what robot has in terms of those abilities. Especially as human, the more we do things, the more they start to get boring to us. So you do something for 50 years or 20 years, you discover that that thing gets boring. So when it starts gets boring to you, what do? You start making mistakes. However, a robot can do something over and over again with the required precision. On the other hand, when we look at automation, we look at the application of technology to monitor and control the production. That means if we are looking at in a particular factory, if you want to monitor or control the production, that's where automation comes in. And within automation, you can even find robotics working there. So I can automate my system with the use of robotics that can assist me for everything to automatically execute as it's supposed to be. On the other hand, when we look at factories, we're looking at highly digitalized and connected environments where all these machines, whether robots or what, or equipment, they're actually able to improve those processes. So I can use many of robots in my factory to communicate with one another, to be connected, to achieve whatever I want to achieve. So I'll explain further about all these levels I'm referring to. So when we zoom into robotics, that shows an example of a manipulator, automation, factories. So we now zoom into robotics. So what you see on your screen, it's a simple robot that is normally used in car production, or it can be used in any other pick and place operation in the industry. So if I want to move a box of sweets from a shelf to the floor, and I see it's not safe to do so, I can program a robot to do so on my behalf. Hence, you see this robot. So what are the things that robot can do? Again, I repeat, robot can perform tasks faster than human beings and much more consistently and accurately. So what does that mean? It means that we need them in our production. We need them in our daily lives. Also, robots can be used in carrying out repetitive and time-consuming tasks efficiently. So can I ask from the floor, which of the tasks do you think they are more repetitive? That means you do them over and over again. Based on the things that you do in the house, at home, what are those things that you do over and over again?
Washing the dishes.
Why Washing the dishes. Yes, you do them
Making my
over and
bed.
over again. Say again.
Making my bed every morning.
Making your bed every morning. Yes, you do it over and over again. What else?
Cleaning.
Sleeping
Cleaning.
every day. Washing the
Yes.
dishes.
Yes. What else?
Cooking. Brushing teeth.
Yes, brushing teeth. That's what you do. That's what we call a repetitive task.
Cooking.
I'm sure most of you are tired of doing those tasks. Am I right?
Folding clothes.
But I enjoy it.
Yes. So I'm sure most of you are tired of doing those tasks because you do them every day, right?
I'm doing my work.
Yes. Just imagine if you can do a robot that can assist you in those daily activities. Will life be better?
These guys think robots can do their schoolwork. One robot that do their schoolwork.
Yes.
No.
Yeah.
Or a robot that can do your
Go to
homework.
school class and teach us.
Wow. So robots can adjust their parameters like speed and time to execute tasks. And they are also designed to work in harsh environments. So what are those harsh environments that you can think of? Environments that are dangerous?
When it's cold.
Of any dangerous
Working in the
environment?
mine.
Yes, in the
Working in the
mine.
mine.
Where else?
Working.
Working at the South Pole.
Working in
places.
chemical.
Working where?
Clean chemical. What do you call it? Tanks. Cleaning
Yes.
chemical
So all
tanks.
those places that you are mentioning, those are some of the harsh
Cleaning
environments,
chemical place.
and those are the places where we need to send robots. Places that are not conducive for human beings to go to.
Working.
So you can
No.
think of many examples, right? Yes. So if we go deep into a robot, we want to understand what are the intestine of a robot. What is a robot made of?
Cables. Cables. Metal.
Mechanical wires.
Yes. So let me just explain to you. This is an example of how a robot is, right? The robot has a processor, which is the internal side of the robot. So that means that's the brain. That's the brain that is processing all the information for it to execute the task that is required. On the other hand, we have systems that are outside the robot, such as sensors. So the sensor, it allows it to able to sense different objects, sense obstacles. So there are different types of sensors. We can have light sensors, we can have chemical sensors, we can have obstacles. Again, on the outside of a robot, we find things like motors. What does a motor do? Does anyone know a motor?
I know it powers stuff like it powers a car.
Yes. Anyone else wants to try?
It moves the robot.
Anyone else wants to try?
It moves the robot.
Yes. So the motor drives some of the system of the robot. So it drives the system of the robot to be able to execute the task that is meant for. The robot has also hydraulics that also allows it to lift heavy objects. So there are various things that are within the robot and also outside the robot. So these are the things that you're supposed to know so that you are not surprised why a robot cannot be like us. So again, we move on to, when we look at automation, what are some of the benefits that we can get from this? We can achieve low cost when we do automation. We can also improve worker safety. We can also increase our production output. So meaning we're able to do more with less resources. We're able to improve worker safety because tasks that are boring to humans, that are taking time when humans are doing them, they are also taken over by those systems. So we can lower costs, improve safety, and increase our production output. So that means we can make more products at the end. So,
hi guys.
an example of a product. Does everyone have a soccer ball?
Yes.
Yes.
Okay.
No. Yes.
Yes, some of us have a soccer ball.
Yes.
So,
Yes, we have a
so see a soccer ball as a product, right?
Yes.
A
Yes.
soccer ball is a product. So if there are many kids in South Africa that needs the soccer ball, so imagine if humans have to make each and every soccer ball for each and every one, how long it will take?
Forever.
Forever. Yes. So that's where automation comes in. So we can use automation, which makes the use of robots and other machines that can assist us to make things more faster so that we can see a lot of soccer balls in the shops. Right? So that's the advantage of automation. Does everyone understand?
Yes.
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 Thank you. So we now move on to factories. So what do you understand about smart factories? Let's see if you are clever. Just show with the raise of hands so that we can recognize you. What do you understand about smart factories? Or what do you understand about the word factory? What is a factory?
Where they sell stuff.
Where they build stuff to sell them. They
Yes,
build the
where they
stuff.
sell stuff, where they build stuff. What else?
Automation.
Where automation happens, right?
Where they manufacture,
Londi, where you are saying?
where they manufacture things.
Yes. Ubenati, what do you think? What do you think is a factory, Ubenati?
I don't know.
Did you hear what the others were saying?
Yes.
No.
Yes, so let's learn more about factories.
Yes.
So we said a factory is where they make stuff, right? Where they produce products, where they make solar. Yes,
But actually,
the shows
robots
a
make
factory.
them.
So you can see that within the factory there are robots, right?
Yep, we can see it.
What else is there in the factory?
Humans.
Worker.
Workers, yes. We've got workers. What else?
I don't know. Machines.
Dangerous
We've got
chemicals.
machines, yes. What else?
Bookshelf. I need shelves.
We've got shelves.
Computers.
We've got computers.
Dangerous
Yes.
chemicals.
I got
Yes, so
computers.
we've got all these kind of things within factories, right?
Yes.
So let's all listen. So we've got all these things within factories that help us achieve the kind of productions that we want to achieve, that help us to produce the products that we want at the end of the day. So we mentioned different kind of products. I said, see a soccer ball as a product, right?
Yes.
So see a soccer ball as a product is produced within a factory that is composing of robots, human beings, machines, computers, and so on. So all these things works together towards achieving that common goal. But when we say a smart factory, we are saying a factory where everything communicates. That means where robots communicate with human being communicate with a machine, computer communicate with another thing within the production. So if everything can communicate with one another, it means things can happen faster, things can happen more smartly. So that's the kind of smartness I'm speaking about. So within the factory itself, we can process what we call big data. That means it's information that can help us to understand what's happening out there, to understand when do we need to change the design. So if a lot of kids in South Africa needs a different ball design, actually these systems, because they are connected, they can actually help us with the kind of information it gives to be able to know when to design this kind of a ball, when to design this kind of a product. So those are some of the things that smart factories can help us achieve. Within smart factories, I've mentioned that they are robotics. So these are smart machines that operate autonomously, and they can communicate together to achieve whatever they want to achieve. So you can see already I've shown you 5 robots, and there are also other robots that you can find in the system, right?
Do they work all night and day?
Yes, so you can work 24 hours. Remember, a human being gets tired, right? Do robots sleep at night?
No.
Yes, so robots are not like human beings. They don't get tired. So they can work over and over to achieve whatever they need to achieve, as long as they are programmed to do so. So you can allow these robots to work 24 hours. And within the production system, we also have 3D printers, right? Does anyone have a 3D printer? What is a 3D printer?
We do not it, but our dad
Yes.
we do
Can
not
someone try again?
usually does. Yes.
What is a 3D printer? Or what does it do?
It prints, it makes a copy. Yes, we do. It's a copy of the you want it to print.
Yes, yes. Anyone else? Let's all try. There are some people that are quiet in the class. Anyone else? Does everyone know a 3D printer?
We do not.
Yes.
Yes, please.
Yes.
I have a 3D printer. Even me.
Yes, what do you do with your 3D printer?
You can make toys with it.
Yes, you can print toys, right?
Yes.
You
We have a
print
lot of toys.
Can you print paper? Yeah,
No.
can you?
Only things that are made out of plastic.
Yes, so depending on the material you're using on the 3D printer, you can able to make that particular product, right? There
And
are
you
also
can make a
plastic
mini
printers.
robot.
There are
Computer
also
mouse.
metal printers. Yes, I can also print a robot, right?
A mini robot's a bad idea.
Yeah.
A mini robot's a bad idea, you know.
It
But
can
they'll be
create
fake.
bots.
Yes, so let's listen. So within the smart factory, I said we've got connected devices, right? All these devices or all these machines, all
Yes.
these are working together towards achieving that common goal.
Yeah.
So that's why we have connectivity within the floor. So those are some of the factories that we see or we regard as factories of the future. So imagine you can get home, your fridge tells you that the milk is finished. Does everyone have that kind of a fridge?
No.
No way.
Yes, that's where technology is going. So next time you come from school, a fridge will tell you that milk is finished. You need to go to the shop.
Wow, just like now, future cars can now talk already.
Yes.
You really got us talking when I wasn't. You and me were talking about robots.
So you can
Sometimes
see how
robots
fast
think-
technology is growing, right?
Yeah.
And they're already figuring out how to make flying trains.
Yes. So when we grow up, we have to learn to start learning to program. We have to start learning to make all these things happen. Because it's us who are going to make them happen.
Yeah.
It's us who have that knowledge. It's us who are wonderfully created. It's us who are created in the image of the Lord, right? So we are going to look at some examples, right? So let me just show you some examples, and then we'll take it from there.
Thank
you.
So I'm going to show you some examples now of some robots.
We can't see
and what
any
they can
robots,
do.
sir. We can't see any. We can't see any robots. Oh, we're now starting to see.
Can you see my screen?
Yes, I can see it.
Yes, please
You can see
watch
it.
and learn. I'm going to ask you questions after this.
Yes. Yeah, we can see it.
Robots are cool. That robot is cool. Robot. That's cool.
Hi. We can see it. Yeah, we can see it. Can even pick stuff out of the sink. Yeah, it is cool.
It's helping. Yeah, it's helping. But why does he look so small?
Maybe it's because it was small.
Is it a dog? What is that thing?
It can climb stairs.
Looks like a dogish, robotish, dinosaurish. Yeah, but what's it doing?
Some robots can go causing mischief.
Okay. So let's see from the class. Let's see if people concentrated, right? So let's not talk all at
Please
once.
raise your hand.
Please raise your hand.
If you have
Raise your hand,
answer.
and I will give you opportunity to ask. Where's my program director?
Yeah.
Yes, please control the program so that everyone answers.
Okay. The platform is open for questions.
Yes, I want them to answer what does that robot do?
I think it helps.
It helps.
Please raise your hand. Hanam Klanga, you can speak.
The robot cleans the house.
Yes. Anyone else?
Yes, there's Mufaro Wedi Zingwevu, you can speak.
Why can robots do things faster than humans?
Yes, I'm still coming to the general questions. I want you to answer me based on what you saw in the video.
Okay.
Londwe's hand is up. Esihle Lole, I'm coming to you. Londwe, what did you see?
The robots were washing dishes and cleaning stuff and throwing stuff. Some
Okay.
things like that.
Okay, Esihle and Emihle.
Yes. Robots were cleaning the dishes and helping other people. And learning.
Jabulo and Mimi.
It was as if they were alive.
I have a question.
Then they were wandering around like normal. Yeah, they were like normal people, but it was even cooler.
Okay, who else wanted to answer the question? Any?
Me?
Any?
There is on the raising hand, there's Naya, there's Stripe
helps
Marange.
out.
Naya, can you please speak?
The robot was helping around the house and acting as a dog, like a dog's that's helping.
Yes. Stripe Marange, you can speak.
The robot was taking plates.
Yes.
Then other hands.
So let's have the last two responses.
Lubanzi and Lunati.
I see no answer.
Lubanzi and Lunati, your hand was up.
Me?
No, me, yes.
The robot was sleeping. Something like that.
Okay.
Okay.
The robot was cleaning up, and when the robot was running to the stairs, it slid over a banana peel, and then it picked it up and threw it away.
Yes, it's like some of us were concentrating. So let's watch another video. Let's see if you can concentrate. Let's see the last one.
Okay.
I'm gonna share my screen again.
Okay. Hello.
So I'm gonna share my screen again now.
Technologies never stay still, especially from inside of robotics, and so are we. So today we will see definite world timelines. And not only one robot can now act, even knows how to perform. Unlike robot analysts and general development of robotics, space shuttles work. The company presents many new robots. For example, a swarm of ants that can interact with each other. Butterflies and dragonflies with the diagram of all the aids and parts of these episodes. When they were created, the company focused not only on their appearance, but also on behavioral characteristics. The ants coordinate with each other all the actions and movements. Each ant, that is 14 centimeters long, has coincidentally a radio module by which precise coordination is carried out. 3D stereo camera in the head of the ant allows it to see, and the infrared optical sensor installed below monitors the movement of the mini robot. Meanwhile, 2 onboard batteries provide up to 40 minutes of wireless ants work, and they are recharged in the dark with the help of their antenna. As for butterfly robots, the weight of each butterfly is only 32 grams. This includes 2 satellites, a pair of small batteries, and a laser mid casing. After one charging that lasts 15 minutes, butterflies will be able to fly for about 4 minutes. And their flight looks very impressive. They're not just butterflies, but a whole system that consists of 10 high-speed infrared cameras.
We cannot hear very clearly.
They track the infrared markers and follow the robot.
You are right.
With the signal to care. So that kind of coordination of butterflies is going in the space. You can hardly distinguish the pilot and butterflies.
Sounds like a robot speaking. I can't hear clearly.
Seagulls and dragonflies that can fly just like they live in water. A seagull was developed in 2012. And a dragonfly that can hang in the air so much that its natural counterpart was invented. All the details of the dragonfly were made on a 3D print. And you can control this miracle with a smartphone. For these developments, the company could add out the development market of ground truth, but it doesn't need it. The technology of flying and hovering in the air has worked on these 2 prototypes. The core of the bionic kangaroo is a mechanism of locomotion. It uses the energy recovered from one job to locomate another. Real kangaroos quickly get tired and cannot jump for a long time without the mechanism. Things that store mechanical energy overweighted in different ways on the outside are used in this project. A bionic kangaroo that weighs 7 kilograms and flies 1 meter can make a jump of 80 centimeters in length and 40 centimeters in height.
The sound is unaudible.
Yes, what did we see?
We saw robots that look like animals that are real.
We saw robots.
I saw that.
Wait, let's give each other a chance. There are people who want to
Let's
ask
start with
questions.
those who have. Let's start with those who have raised their hands. The first one who I see is Nomi. Please speak. You may speak.
I saw the robot that can turn into a car in the transformer.
Wow, Nomi. Well
Mufaro
done.
wedu Zimbabwe. Mufaro
I
wedu.
think the cars.
I saw robots cooking and lifting up boxes.
Wow.
Matembe and Nomtandoz Dazo.
I saw a robot going into war like a soldier.
Wow,
Yes. Then
wow.
Steve Marange.
I saw a robot ants.
I was about to say that.
Okay. Any more questions? Any more?
Please raise your hand.
If you have a question or have an answer.
I see you, Nevantu. Uvenati, yeah. I see you are raising your hand.
I saw robot animals.
Yes.
Muta, you are raising Muta.
I saw robots that looked like real animals. The robots that I saw a kangaroo robot, then I saw a bird robot, then I saw a butterfly robot, then I saw a dragonfly robot.
Yes.
Lon,
Muta was concentrating.
Londa, you can speak.
I saw robots working, and I don't know. I saw robots working.
Any you can speak. Any you can speak.
I saw a giraffe robot.
Alicia.
Any more question? Any more answers? Since there's no one.
No, I see Njabulo was raising. Yes, Njabulo.
I saw there was something interesting about the animals, especially the robot ants. They were acting as if they were real ants, but they're actually made out of mechanical devices and stuff like that. And material.
Yes. So Njabulo, do you think you can design it?
And metal. Of course, if I had the tools. Yeah, I could.
Wow. Let's see Esihle.
I saw robots that look like animals.
They look like animals. Yes, they look like animals.
And I
Is there anyone else?
that can jump high.
Yes.
We've got Favor and Angel. Please speak. You may speak.
I see Ona. Ona is raising hand.
Okay, she can speak.
Ona, speak.
I saw a transport robot and a ant robot and a butterfly robot and a kangaroo robot.
Yes.
Is there anyone else who wants to answer?
Last one. I see Ona.
Again.
Lunati.
Lyle,
I can't.
Lyle, please speak.
I saw a kangaroo robot.
Yes, it jumps like a kangaroo, right? Okay, so I think let me just finalize my presentation and then we can ask other questions.
Dr. Boitumelo, you are muted.
So we have seen these different kind of robots that can assist us in our daily operations. Remember, we have mentioned that these robots can assist us for tasks that are repetitive, tasks that are dull, tasks that are boring, and tasks that are dangerous. So those are some of the things that we use robots and we think that robots can assist us to do. So I think this brings us to the end of my presentation. So at your own time, please go and read Exodus 23. You can also look at King James Version and also look at 1 Corinthians 2, verse 16. So I would like to thank you for attending the sessions today. I hope you found it
Interesting.
I found it super interesting. I hope one day I can build robots.
Thank you.
Mommy, we have a question.
Bye.
One question.
Bye-bye.
Mommy, we have a question.
Bye, everyone.
Hello?
Bye.
Questions.
Say bye.
Questions.
Any question? I'll take 2 questions. Remember, we said we are going to give you a test, right? So I'm going to send a link to Dr. Shepard so that we can able to write the test. We'll see if we understood what was presented. So the test, it will be based on what transpired last week and also what transpired today. So for those who are listening, I think it will be a very good exercise for you. And for those that have high marks, after everything is done, we are going to ask them to come and build a robot. So if you don't pass the test, then unfortunately you cannot build a robot.
We have 2 questions.
Yes.
2 hands, I mean. There's Nomi and Mufaro. Do Nomi, you can proceed. Nomi, you can proceed.
Okay, so I wanted to ask that the first video that we saw, it was about like robots, like those dog robots, and so there is something like that which I saw, and those robots, like, they got out of control. And what will happen if they just get out of control? And they can get in like power over us?
Thank you.
I mentioned from the beginning that there is nothing that supersedes a human. So we are the human that able to program those robots. So there is no way that they can actually supersede what we ask them to do. So I program it to wash dishes. I program it to go up the stairs. So it means I'm the one with the power. I have the power to switch off the program if I need to switch off the program. So we will develop those robots. However, we need to be in control at the end of the day in terms of the coding that we put into the robot.
Yes. Well, Mufarawadu, you can proceed with what you wanted to say.
Can robots run off and cause mischief?
That's almost the same question as what Nomi was asking.
So the robots can't cause mischief because it's a human being who programs them, who tells them what to do. So they cannot do anything except what they are told. For instance, if you tell a robot to wash dishes, it cannot go and switch on the TV and switch off the TV. No, it will only wash dishes. That's what it will know. Okay.
Mm-hmm.
Last question.
We have three hands. There's Renaya, Charles Guara, and Esihle, Loli, and Emishle. So I'll start with Renaya, then Charles Guara, then Elisha, then Esihle. Then we'll wrap up and there are going to be no more hands, please. Renaya, you can proceed.
Is there something called nanotechnology? And what inspired men to build technology and robots?
What inspired men to build technology and robots?
And what is nanotechnology?
This is just like a series I'm watching. It's about when men build technology to do stuff for them.
Okay.
Yes, I see we have clever ones in the class to answer your question of nanotechnology.
Okay, thank you.
You can answer, Doctor.
Charles, you can ask your question.
Okay, why is it that people shape the robots into animals instead of maybe shaping them into people, because it's the people who do the tasks sometimes?
Yes, I think that's a very, very good question. So there are different types of robots. So you can make a robot look like anything. As you have seen in the video, I can make it look like a butterfly. I can make it look like a kangaroo. I can make it look like even a human being. So they are what we call humanoids. So those are the human robots that can also, we can use them on the front doors of companies to talk to people, to welcome people. So it's up to us how we want to design those robots. So sometimes we design them based on the capabilities of some of these creatures, what they can do. If like a springboks can jump 2 meters high, that means if I want to do a robot that can jump 2 meters high, that means I'll learn from how it does it, and then I'll be able to program my robot to do the same.
Thank you.
Thank you.
Now, Esihle, Loli, you can ask your question. You may proceed.
You tell a robot to do something and the robot is not programmed to do that thing, what will happen?
If the robot is not programmed to do what it was meant to do,
don't do it.
It will not do that task. So if you just program the robot to welcome people, it will only just welcome people.
What happens when the robot gets under control?
Yes, remember, that's why I'm saying you need to be in charge of your technology. It's you that developed the robots. It's you who knows what the robot is capable of. It's you who coded the robot. So if it does anything outside the scope, it means you need to go back and fix the program. You need to know where are the safety features to consider when such things happen.
Yes.
There is
Thank you.
Anesu and Ona. Anesu and Ona.
Are they raising their hand?
Yes. Anesu,
Okay, but how do they make the robots?
Yes, so this is what we are going to do after writing the test, right? I think a lot of people mentioned that they have a 3D printers at home. So you can 3D print the robot and also get other components that I've mentioned, such as motors, such as sensors, and then put them together. And then we start programming it to do what we want it to do. So when we start doing the hands-on activities, that's when you understand how it's made. But for now, just understand what it does and what are the features of it.
Ona,
Thank you.
Ona, what's your question?
What do you want to ask?
Ona doesn't have a question anymore. Are we guys done?
Yes, we have finished with taking questions.
Before we go, if you have a brother and sister that is doing matric, please call them to come to the screen. I want to do something. If you have a brother or sister who is doing matric, mathematics, physics, and chemistry, please call them to come to the screen. I want to share something for them. If you have your brothers or sisters, they can check those details. Someone is doing geometry and physical science, chemistry and physics for matriculants or for matric students. So those are the contact details. We will share them again next week. All right, over to you.
Thank you. Thank you.
My dad wants to say something.
Your dad?
Yes.
Okay, just one moment. Where am I? Stop sharing. Okay, where is your daddy? Where is your dad?
Hello, everyone.
Hello, I can't see. Where are you?
I think they muted this video. Hi.
Oh, okay, yes.
Can you see me?
Yes, we can see you.
Yeah. I just wanted to say thank you very much to Dr. Ramatsetse. Is he still here?
Yes, he's still here.
Yes, I'm still here, Prof.
Okay, yes. So it's really an honor to work with Dr. Ramatsetse. Dr. Ramatsetse is one of the engineers that I work with. He is also at the moment currently assisting me with the work that we are doing at the place where I think Dr. Shepard Mpofu passed through on last week's, sometime this week, on Tuesday. Was it Tuesday?
Yes.
Yes, on Tuesday. I hope they gave you an opportunity to walk around.
No, they didn't.
Okay, so the next time you come through, I'll kindly ask you to please make sure that you do walk around so that when you come and talk to the guys as well, you can just brief them about what is going on. So I just wanted to summarize Exodus 20 verse 3. I hope the boys and girls have their Bibles. Boys and girls